is greater than 16.2 meters. So we know we're going to be solving for time here. This is a solving question. So let's start with the original equation. The next thing I should do to make sense of this problem is to draw a quick sketch. So we know a ball is being thrown. We can assume that it's not being thrown from the ground, although it might be. We can assume not, though, because we can very quickly solve for that y-intercept, and it's not going to be 0. The ball would look something like this. So if the question is asking how long is the ball above 16.2 meters, we can assume that 16.2 meters has to be below that maximum height, because if it was higher than the maximum height, it would never be higher than that. So let's assume that 16 meters could be somewhere like here. So if we were to solve for t when h is equal to 16.2, we should get two different solutions. We should get one solution on the way up and then one solution on the way down. So whatever that solution is, so let's say that this is t1 and this is t2. If the question was asking, which it is, how long is it above that height? Well, we'd have to check what is T1, what is T2, and what is the difference between the two of them, because all between those times, as you see, the ball is going to be 16.2 meters or higher. So what we need to do is we need to first solve, when we plug in 16.2, what are the two times that the function will give us, and then we need to subtract them to see, well, between which two times or for how long is this ball going to be above this height. So we know that the height of the ball is 16.2 meters, so that's what we're going to solve, that's what we're going to replace with h at t. The height is 16.2 meters. So instead of writing h at t, we're going to write 16.2 meters equals 1.5 plus 119.6 t minus 4.9 t squared. And we know that we are not asking to find the maximum height, so we have plugged in a height, and now we're just going to solve for t, which is here. It's hard to see with this writing, but you guys can write it better on your papers. So the first thing we need to do to solve for t, whether we're using completing the square, or we're using factoring, or we're using the quadratic formula, we need to make sure that one of the sides is equal to 0. So I'm going to bring this 16.2 over to the other side, and we'll collect like terms. So we have 0 equals 1.5 minus 16.2 plus 19.6 t minus 4.9 t squared. Continue to simplify. We've got 0 equals 1.5 minus 16.2 is negative 14.7 plus 19.6 t minus 4.9 t squared. So going through my options, I again could graph this. That would be difficult. I could complete the square, get t by itself. I could factor. I could use the quadratic formula. I'm not required in any other part of this question to complete the square, so I'm going to avoid that step. I don't want to factor this because of all the decimals, so instead I'm going to use the quadratic formula. Now you can't go start using it right away because first you have to put this in standard form. Otherwise you'll think this one is A, this one's B, and this one's C, when actually this one is A, this one's B, and this one's C. So first we need to put that square term first, and then the degree 1 term, and then the constant. So I'm going to rearrange it quickly. We'll have 0 equals negative 4.9 t squared plus 19.6 t minus 14.7. Okay, so now we have our A, our B, or C. A equals, B equals, and C equals. So our A is equal to negative 4.9, our B is equal to 19.6, and our C is equal to negative 14.7. So if we plug it into our quadratic formula, we'll have x equals negative b, which is negative 19.6, plus or minus square root of b squared, which is 19.6 squared, minus 4a, which is negative 4.9, c, which is negative 14.7, all divided by 2 times a, which is negative 4.9. So our x will equal negative 19.6 plus or minus. Make sure to simplify whatever is in that square root. And that's going to be 96.04 all over 9.8. Negative 9.8. Okay, so now we're going to have our two solutions. We'll have our first x value and we'll have our second x value, and our two x values are going to come from the plus or minus here. So the first one's going to be negative 19.6 plus the square root divided by negative 9.8, and then the same with the subtraction. So if we were to take negative 19.6 plus this square root all over negative 9.8, we will get an even number of 1. And if we were to do the same but subtract, we will get 3. So now looking back at our work, we've actually been using x's, but our independent variable actually is an x, it's t. So from this equation here, I've got t, t, t. So actually all of these x's should be t. So I'm just going to write t on top of this. We're really finding t. So our first t is 1 and our second t is 2. So if we go back up to our graph that we made, the first point in which the ball reaches a height of 16.2 is at 1 meter, and the second point is at 3 meters. So if I fill this in here, the first point was at 1 meter and the second point was at 3 meters. Well, the question is, for how long is this ball over the height of 16.2 meters? And that answer would be for 2 seconds, because the first time it hits it is at 1, the second time it hits it at 3. So how much time has gone on in between? 2 seconds. So the final answer is therefore the ball will be higher than that height that they gave us, 16.2 meters, for 2 seconds. Let's work on the last example that we're going to work on right now, which is number 4. So it says that two whole numbers differ by 3. So that means when you subtract them, it should make 3. When you add the sum of their squares, it should be 89. What are the two numbers? So again, we're not given an equation here, so we've got to come up with an equation. So let's use the tricks that we used in previous lessons to try to come up with a quadratic equation here. So first I'm going to create a linear equation from here. Before I create a linear equation, though, let's just set up our variables. So we need two variables for the two things that we don't know. We don't know what the two numbers are, so that's easy. So instead of using x and y, you absolutely can, but I'm just going to use two different letters. So I can use, let's say, m and n. So let m and n be the two unknown numbers. So the first equation that we can come up with is this linear equation here, that they have to differ by 3. So that means when we subtract both of them, they must equal 3. So the first equation would be when we subtract m and n, they have to equal 3. So there's our first equation. It says the sum of their squares is 89. So I'll write this first guy here. The second guy is that the sum of their squares is 89. The sum of their squares, so we've got to do m squared and sum, so plus n squared is equal to 89. So there's both pieces of information in an equation form. Here I see that this looks like it could become a quadratic. Right now it's a circle. So, but I really need just one variable here in order to be able to solve this. I can't solve something with one equation if I have two unknowns, but I have this other equation here, and it's a linear equation. So I can isolate for one of the variables, the easiest one, which would be m, and then plug it into my other equation. I'll be left with one variable. So let's go back to this first linear equation and isolate for the easiest variable, which is m. So I'm going to say that m is equal to 3 plus n. I'm going to box this guy. Now what I can do is I can substitute this into the second equation here. So instead of m now, I can write, well, that's the same thing as 3 plus n. So instead of m squared, I can write 3 plus n all squared plus n squared equals 89. and keep on simplifying. 3 plus n all squared, well that's the same thing as saying 3 plus n times 3 plus n all plus n squared equals 89. So let's expand this very quickly. I'm going to skip some steps and collect like terms. So it's once you simplify it, it should be 9 plus 3n plus 3n is going to be 6n plus n squared equals 89. If you need to do that in multiple steps, I added the 3n and the 3n together. Do it in multiple steps. That's absolutely fine. Okay, so now our next step is we have to solve for n. So we're going to collect like terms and then make a decision from there. Also, I notice I have like terms in 9 and 89, so I'm going to bring the 89 to join the 9 so that we have 0 on one side so that we can use either factoring or quadratic formula to solve this. So on the left, I'll have n squared plus n squared, which is 2n squared. I have plus 6n. And then I have 9 minus 89, which is going to be negative 80, equals 0. So now, as usual, I have a few options here. Again, I'm solving for n. The question's asking what are the numbers, not what's the maximum, minimum. I'm not finding the vertex here. Okay, so I could solve this by graphing. I could solve this by completing the square. Again, not asking for vertex form, so I don't want to do those extra steps. I can solve this by factoring or quadratic formula. These numbers actually look pretty nice. Why don't we try factoring? Quadratic formula will always work, and we're going to use factoring if we think it could be efficient. I notice that there's a greatest common factor in all three of these terms, and that would be 2. So let's take out the 2 first. So we'd be left with 2, and then we'll have n squared plus 3n minus 40 equals 0. So now that we factored out the 2, our a value is 1, so we can actually use the shortcut of sum and product. So we're looking for two numbers that multiply to negative 40 and add to 3. And if we think about it, those two numbers could have something to do with 5 and 8, because 5 and 8 multiply to 40. They have to make positive 3. Let's put the negative in front of the 5. And let's triple check. So negative 5 times 8, that's going to make negative 40. Negative 5 plus 8, that's going to make 3. So here are our two factors. So when we factor this, we've got 2 times n minus 5, and then n plus 8 equals 0. So now we can find our two values for n. So our first value is going to be for n is 5, and that's because we're setting this factor to 0 because we've got 0 on this side here. We're saying what does n have to be to make this part equal to 0? Well, n has to be 5. And then we'll have our second solution, our n2. That has to be negative 8. So this gave us two solutions. Let's go back to the question and see if both of these solutions are okay or are acceptable. So it says two whole numbers differ by 3. So if you go into the definition of what a whole number is, the set of whole numbers are the set of positive integers including 0. So a whole number, we'll just write a little note here. A whole number is a set of numbers 0, 1, 2, 3, 4, etc., etc., etc. So because this question said that the numbers have to be whole, that means that the only reasonable solution is this first n that we found. This one is not a whole number. Not a whole number. Okay, so we know that n has to be 5, and the question was asking what are the two numbers. So we found our n. Let's find our other number by using this original linear equation. So we know our n is 5. What would our m have to be? So m would equal 3 plus, we know n is 5. So that means that m has to be 8. So therefore, our conclusion would be that one number is 5 and the other number is 8. Now that you've completed these examples with me, we've done enough different styles of examples that you should be able to do number 5 on your own. We're going to skip number 2 for now. and you can continue with your homework assigned for this lesson.